at this point, you actually do have a pretty good understanding of monochrome. There's a lot of cool things you can do. And just for example, we already were able to make the intro video. However, there's a few things that we're limited in right now. So let's talk about three of them. So number one is, what if we're transforming something and it's not matching the way we want? So what this means is that whenever I'm matching something, it's the monochrome has to make an assumption about, well, this guy has to be mapped to the final output, right? This guy has to be mapped to some mesh in the final tree. Okay, so that was phrased a bit weird, but basically, when we're transforming, we have an initial tree and a final tree, and in every mesh in the initial tree, I have to match it with some mesh in the final tree. And that matching is somewhat arbitrary. I do make some guarantees that'll make it usually do what you want, but of course, there's of course a million different ways we could transform. There's a million different ways we can match. So inevitably, it'll be the case that it'll do something that you don't want. Let's take an example right here. So over here, what I want to do is I have a set of bars. Oops. I have a set of bars, and what I want to do is I want to sort them. But when I just do a transform, it's not emphasizing the sorting because it's just adjusting the heights of every single guy. So technically, the initial state and the final state was what I wanted, but the intermediate state, the way it got there, wasn't what I wanted. I wanted it so that, well, say we have the smallest element, I wanted it to somehow move to the final state. But that's not what it's doing. Okay, so that's kind of the problem. And then the other problems is, what if we want to apply an operation to only some parts of a mesh tree and leave the rest unchanged? And similarly, what if we want to apply an animation to a subset of a mesh tree? I think these ones are slightly harder to motivate because if you're doing something like this, it takes more complexity. So the examples we'll see are more toy examples. But there are definitely cases where you only want to apply an operation to some parts. But again, those are a bit advanced. Anyways, let's talk about how we can solve this though. So we can solve all of this via tags. Maybe you've noticed this already, but almost every single mesh has an argument for tag, and we've been just leaving it empty for now, but it does actually serve a purpose. So what we're going to do is that every mesh in a mesh tree, it'll have an associated list of numbers. And the key idea is that if I give each mesh a unique vector, or I choose the vector in a clever manner, then it'll be very easy for me to choose subsets. And if we can pick subsets very easily, then problems 2 and 3 are very easy to solve, because then I can just specify only apply this operation to this set of tags. Okay, so how does this solve the first problem? The first problem does seem a bit unrelated. But really, the problem that we have is an issue of identity. We don't know that this mesh in the rich, we don't know, a priori, we don't know that this guy, this minimum guy, and this guy are really the same object. Excuse me. So we need to have some sense of identity, and tags provide that. So what we're going to do is I'm going to modify this example slightly such that in the initial state, the tag is just the index. And in the final state, the tag will be the index from where it came from. And now if I do a tag transform, it's going to look at, say, okay, I'm going to match tags in the initial tree with the meshes in the final tree that share the same tag. And if we do that, and since we set up the tags properly, we'll get exactly what we want. Right? So maybe I'll play that again. Actually, we can just... Right? We can see that it's much better emphasizing the nature of the transform. Okay. Another thing is that there's this thing called right key. It does help out a bit. I'll let you read that if you're interested. Okay, and or maybe not very similarly, but somewhat similarly, we can still use the same tagging scheme, where I'm gonna assign each bar with its index, and then I'm going to apply an operation to only part of it. So here I just shifted up some of them, which again is a toy example, but nevertheless highlights the idea. Okay, other things I will emphasize is that over here we've been having every single mesh have a unique tag. That's not always what you want to do, and that's not what you even have to do. Like for example, by default we've just been having everything give the empty tag, so it's certainly possible, certainly allowed to have multiple meshes be given the same tag. And in fact, you might want to do that when you want to have multiple meshes sort of sort of being considered the same object. Like for example, in the cardioid, maybe it would make sense that this gray circle and the line and the lines together have the same tag, because even though that they're separate objects, we still might want to treat them as one in some sense, or their sense of identity is shared. That's the idea. All right. Okay, we actually didn't talk about too much about tags, just because I think that it could get pretty advanced. But maybe in the future we'll also see how tags can be useful. But definitely that what you have to know is tags provide a sense of identity and they allow us to choose subsets. That's the two things that they're good at.